Numerical Computation, Chapter 11, Video 3. In this video, we take a look at a Laplace equation with the more non-homogeneous Dirichlet boundary conditions. So last time we looked at a condition where three sides are homogeneous and only one side is non-homogeneous. In this lecture, we look at a general non-homogeneous. So we would assign values of u on all four sides on the unit square. So this will be our boundary condition. So on this side, it's a function of x. Let's call it h of x. On this side, the boundary condition changes and y varies here. So some function of y, call it fy. And up here, we call it gx, and that is the same as last time. And on here, the y varies and x is 0. So this is some function of y. We call it m of y. We noticed last time already that the boundary conditions only enter in the load vector B. The coefficient matrix A remains unchanged. So what one needs to do here will be, you could go through the grid again with the computational stencil, in particular all the grids that touches the boundary point, and then collect the contribution of all the boundary terms and move them to the load vector on the right hand side. So take, for example, n equals to 4. This would give us the first equation. You are here, computational stencil touches this one, and these two will go to the right hand side in the first element, and they change into negative sign. For the second equation, v2, your stencil will touch h at x2, so this got moved to the right hand side. And when you move on to v3, your stencil will touch h, x3, fy1, and they appear on the right hand side. And now you move to v4, and then your stencil will touch this one, and that moves to the right hand side. And then if you're in the middle, you don't touch any boundary points, so 0. And when you're at v6, your stencil touches fy2, you move it to the right hand side. And then at v7, you touch my3, gx1, and you collect them here. And the equation number 8, you touch gx2, so that goes there. And the equation v9, number 9, you would touch fy3 and gx3, which you collect here. So I hope that procedure is clear, and we shall be able to do this for n larger. So say n equals to 5, and we can go through the same procedure and get this B load vector. So the first one will have many boundary terms, and then the first and the last of the first group will touch two boundaries. And then in between, only the first and the last will touch the boundary, and then the inner ones will be completely interior. And then this is also an interior sweep that touches the boundary only on the first and on the last. And then the last sweep, you touch all the boundaries in G, and then the first and the last one touches two boundaries. Okay, so hopefully the pattern shall be clear by now, and you can easily write this out for n equals to 6 or 7. All right, so hope you enjoyed it, and see you next time.